Hello, everyone, and welcome. This is Professor Thayer with you here today to talk to you about variables, expressions, and programs. So we're going to continue on our discussion about Python. Let me go ahead and share my screen for you. As usual, you're welcome to follow along in the video or with your local copy of slides, whatever works best for you. And we can start on the first slide. All right, so today we will talk about the expressions, values, and types, and we will talk about various other aspects of these statements: overloading variables, programs, prints, and comments, a number of these things, which all go together under the umbrella of variables, expressions, and programs. So let's take a look at expressions and values. This is actually probably a concept that you're relatively familiar with already, although you just may not know it by those words. Have you ever used a four-function calculator or even a scientific calculator? You know, those little pocket calculators, or maybe you have one on your phone. And suppose you wanted to know what is 2 plus 3, right? What would you do? You'd pull out your calculator and you'd type 2 plus 3 and you'd press the equals button and it would evaluate that answer and show you 5. Expressions represent data. The 2 plus 3 represents the idea of the number 5. Evaluating an expression will tell you what its value is. So, for example, of course, 2 plus 3 is equal to 5. You can find this information out in Python just like you would on a calculator, although it's going to look a little bit differently. So now this here is showing you the interactive interpreter in Python, which you recognize by these three greater than symbols or the chevrons. This is basically your prompt where you'll type and then you type your 2 plus 3 and then Python shows you the answer and then you get another prompt for the next thing. I will mention that depending on which version of Python you have, you may see this bar like this, or your prompts may be recessed on the other side. But it's all the same thing. It's just a different format. So you shouldn't be concerned if you see it in one way or the other. So that's what it means to evaluate an expression. And Python is able to evaluate math expressions and many other expressions, which we will learn about in the course. Now, I'd like to do an aside about notations in the slides, so you'll be sure to understand what we mean. So often we'll be providing the general syntax and specific examples of something that we want to talk about. So the syntax means the components and order components in some kind of an expression that we want to say. And so we'd indicate the variable part using the angle brackets, just like I'm showing you here. So you shouldn't actually type the angle brackets. You should type the thing on the inside and fill it in with your thing. Okay, so for example, if we want to type some expression, we don't type the angle brackets, we substitute in that 2 plus 3 expression. So typically, when we're talking about something new, I will show you the syntax in a more general way, like, for example, print my string. And then I will also show you some more detailed example below where I've actually substituted in some particular instance. So this is the more general way, and this is the more specific way. And what we're showing you here is which parts are going to be common to all examples. And then here is one particular example for you to be able to use. I'll also use the Courier New font in bold to show you things that should be typed out on the computer and to highlight the Python keywords so you will recognize those. It kind of looks like typing on the computer. That's what I'm trying to suggest with that. So getting back to what we were saying, expressions and values, the value is equal to the original data. If 5 weren't equal to 2 plus 3, then we'd be in trouble. The value is expressed in what we call the canonical form. And so canonical form means, well, you probably heard this term in relation to fractions, right? So 1/2 is equal to 2/4 and so on. There's an infinite number of ways we can express the same idea as 1/2, but we would put it in the reduced or the canonical form so that there will only be one answer that we can all agree upon is the way that it should be expressed. And so if Python sees an operation that isn't completed, like 2 plus 3 could be resolved to 5, it will go ahead and do the math and then show the answer. And that's what we mean by canonical form. And so there will be other operations that we will talk about besides addition, like working with text, which is called strings, to actually, answer the question or like solve the problem. And so when it shows the answer, it will do all the things that it can do, and that will show it in canonical form. So obviously Python can evaluate expressions. We've just seen that. Python in the interactive mode can interactively evaluate the expressions just like it would on a calculator and display the resultant answer on the screen. So Python is a simple expression language. This would mean that we need to have some components in order to make it work. We'd want to be able to work with integers and float values, that is, things that have decimal points. We'd want to be able to do math problems, arithmetic. We'd want to be able to do comparison, greater than, less than, Boolean values. So this would be the true and false, and then to be able to apply that Boolean logic. So let's go ahead and take a look at a few of these things, because these will make up the building blocks of what we can work with in a simple expression language. These ones I'm sure you're already familiar with. Doing arithmetic, the four basic signs, the plus, minus, multiplication, and division, and these can give us numbers that fall on the real number line, which include numbers that have decimal values. They could be positive, negative, equal to 0, and so on. So addition and subtraction use the plus and minus symbols. As you're familiar with the multiplication, instead of using the cross or X, we'll make use of this star, which is on the 8 button. You'll use Shift and 8 on most standard keyboards. And then we would have the floating point division. So we don't use this division symbol, but instead the fraction style. And you may know from your algebra class that fractions really can just be another expression of a division problem, numerator divided by denominator, which is why we use this symbol. We also have this other kind of division, floor division, which we'll have more to say about in a few moments. And then the remainder or mantissa operator, which is related to the floor division. So just hold that thought. I'll tell you more about that in a moment. And we would also want to be able to exponentiate, raise something to the power of. Now, you may be familiar with using the caret, which is like a little up arrow looking kind of a thing. But in Python, we do not use the caret symbol. We use the double star to indicate exponentiation. We'll be practicing with all of these so that you can help you to just remember all of those things. We're going to also have equality and inequality. Remember, big mouth, big number, little mouth, little number. So we have the greater than symbol and the less than symbol, these two right here. And here we have them larger in cartoon. And then there's also the one greater than or equal to and less than or equal to, which you may be used to seeing with that line underneath the symbol. In Python, we express this as two symbols. So this one is less than or equal to, and this one is greater than or equal to. So it's two symbols acting together as just one operator. Then we also have the is equal to and not equal to, which will express equality and inequality. You may be familiar with these symbols from your math. The equals symbol is distinct from the single equal sign because it's asking the question, are these things equal to each other? And the not equal to features the exclamation point, which in Python means not. We'll actually see this in other situations. So exclamation equals means not equal to, which is this symbol here, which you may have seen in some other situations. So in Python, there is this concept of type. And what is type all about? Well, do you agree that dog and 3.14 are not really the same kind of a thing? You might want to do math with 3.14, but you probably are not so interested in doing math with dog. You're probably interested in somehow processing that text, maybe putting it into a sentence or something like that. So we have this idea of types where we have different attributes associated with them depending on what their type is that makes sense for working with that kind of data. It's useful to have the different types, each with their own associated actions, and this is part of the object-oriented approach in Python programming, or well, really in object-oriented programming in general. That idea of having a type and having certain things that you can do with each one. So we would say that one is text and one is a number. And can you think of even other kinds of data that we'll store with them, and what are the kinds of actions that you'll want to do with them? We'll get to see a few today, and also the concept of type can be much more broad in Python, even to extend to data structures, such as a list of items. So we will see what those various types are and what one might do with them. Let's get a more formal introduction to types. Types classify expressions. Now remember that expressions really just simplify down to one thing, the canonical form. The type of an expression is always the same as the type of its value. Some types we'll encounter today are integers, which you might have seen in math, floating point decimals, that's the things that have the decimal components, strings, which is the way that we express the idea of text in Python, and Booleans, which refers to the types true and false. How can you check the type in Python? Well, you can just ask Python to tell you. You would use the keyword type, and then you'll have these parentheses here, as we do for all Python functions and methods, and then we would put an expression inside. So here are some examples. Suppose we want to know, Python, what is the type of 3? And it tells us class int. This tells us it is an integer. Python, what is the type of 3.14? Oh, it's a decimal number. It's a float. Type of cell phone. Oh, this has some quotes around it. It is in green. Notice that Python is using a variety of different colors here. It shows up in green. It tells us this is a string, which remember is how Python expresses that idea of some text. And we do a type of true. This is a Boolean, true and false, right? And this shows up in this orangey yellow kind of a color. So a few things to notice about this is that when Python is responding to the things that you're typing, it will color code this. And this can be really helpful because it will help you know what Python is parsing it and what it is thinking that it is. So the keywords are going to be in this purple, raspberry kind of a color. The responses tend to be in green. Blue. The green is for the strings, things in quotes. You'll see some other things that are in the quotes. And then the Booleans, the true and false, are in the yellow color. Strings are sequences of any characters, otherwise colloquially known as text. It's surrounded by matching quotes. You can use either the single quote or the double quote, but you can't mix the quotes. Their type is str for string. So here are some examples. Hello world, cat. This one's in double quotes. This one includes some punctuation. We've got the comma and an exclamation point and even a space. That's fine. Any character is fine. And here we have the value of pi is 3.14. So notice we've included something inside that looks numeric, but it is being treated as text. This is not behaving as a number. Suppose you didn't match your quotes. Well, you're going to get an error. But you don't have to take my word for it. You can always just ask Python. So we can check the types using the type keyword, the parentheses, and then you put the expression inside, and we can see that all of these are type string. Integers are just like integers in math. They're a number with no decimal or fraction part. It includes the set negative infinity to positive infinity and includes 0. Integers have a type int. So here's an example of some integers on a number line. You may have had this tape on your desk in elementary school to help you do addition and subtraction problems. You can check the type by simply doing type and then providing the number. And so we will see that these are all integers. Floats are the type that is going to include the decimals. So remember that there's this concept of the non-terminating decimal, and usually we first encounter this when we try to do a division problem. So for example, we may start off with 2 integers, 11 divided by 3, and so we see that this is a non-terminating decimal with a repeating 6s, and we can ask Python to tell us about that, and it'll tell us type float, right? But anything that has a decimal component that's numeric is basically going to be considered a float in Python unless you have forced it to become something else. So floating point numbers are variable precision decimal approximations. Some approximations are accurate with just one place, like 0.5 accurately represent 1/2, but others are inexact even with many decimal points. The most famous is probably 22/7, which is pi, which we know as a non-terminating decimal that we oftentimes truncate to 3.14 for our typical calculations. So the idea of floating point comes from this idea that we don't know how many decimal values we're going to need. And in some cases, it's impossible to have all those decimal places because it would be impossible to have an infinite number of decimal places. But for intents and purposes in this class, we can have, like 2 or 3 decimal places is going to be totally fine. But just keep in mind that that's the idea between the floating point numbers, how many decimal places it's going to use to approximate things. So floats have type float, and Python uses the decimal point to indicate that the number has type float rather than int. So remember we had those division symbols, and we had the single slash for the normal regular division, and there was also this other curious symbol with the double slash. And so now let's come back to that and discuss the 2 kinds of divisions that Python is able to carry out. So floating point division is the ordinary regular division. This is the long division problem that you have probably learned how to work with in your elementary school, right? You have the dividend on the inside and the divisor on the outside. This asks how many times does 4 go into 692, or 692 divided by 4, and the quotient which goes up on the top is the answer. And so we see that this one happens to go in evenly. I've worked out the long division, and we have the remainder down here, and the remainder is 0. Here's another division problem over here where we're asking how many times 5 goes into 128, and it goes in 20 times evenly, but it's got a remainder of 3. And so the different kinds of division are going to have something to do with whether it goes in evenly or not. Well, how it looks will be a little different. So when we do floating point division, Python has no way before it actually does the division to know what the answer is going to be, whether it will need decimal places or not. Notice that in both cases, we start with 2 integers. So 692 divided by 4 and 128 divided by 5, these all are integers. This one can be expressed, like the answer can be expressed with no decimal values because there's no remainder. But this one would then have whatever 3/5 happens to be equal to is the decimal component. So there's no way before we get started by just looking at the types to know whether it needs to be a float or whether an integer answer would be acceptable. So what Python does is it always reports decimal. It says, okay, I'm gonna just report the decimal even if it's 0. So you'll always get floating point. So here we got 173.0, although we didn't need it, and here we get the 128 divided by 5 is 25.6. The double slash symbol carries out the floor division. This tells us the whole number part of the quotient. How many whole number times does 5 go into 128, for example? It does not report the decimal part of the quotient, and so the result will be reported as an integer because it's telling you the whole number of times that it goes in. So, for example, we could do 692 divided by 4, and we get out 173 with no decimal point, and 128 floor division with 5 will give us the 25. But of course, it doesn't tell you anything about the remainder. And suppose you wanted to know something about the remainder. Well, we have the mantissa operator, or the percent symbol, in order to do this. The mantissa operator percent reports the remainder portion of the quotient. The remainder is reported as an integer. So it's not the decimal point value, it's going to be how many are left over when you did the math with division and you put the remainder in before you learned how to carry out more decimal places. So, for example, 692 divided by 4 didn't have any remainder, so our mantissa tells us 0 because there's nothing left over, and 128% 5 tells us 3 because we had a remainder of 3. We could also report all of this out here. I'm showing you how to do this in a nice little sentence format. So we're going to print 128 divided by 5 equals, literally, right? 128 divided by 5 equals, and now we have the floor division, which gives us the 25 remainder word right here, literally, and then 128, what is the remainder with 5? It is going to be that 3, and we put it right in here. The percent operator or the mantissa is useful to test for divisibility. If the dividend is evenly divisible by the divisor, the percent operator on that division problem will be 0. So we could use this to test for divisibility by 2, or odd or evenness. So for example, 100 is 100 evenly divisible by 2. It is, and that means that if it's evenly divisible, then there's not anything left over. So we get a 0. But 101 is not evenly divisible by 2, so we're going to get 1 left over. So you'll see that we could write some kind of code that would test to see about divisibility by checking whether the remainder is 0 using the mantissa operator. Let's take a look at comparing integers and floats. Consider 3 versus 3.0. Which one is the int and which one is the float? And we'll take a look at some of these expressions, which will have different types that for its constituents. So we're going to look to see what are their types as written in the problem. And then we're going to ask, what is the type in the answer? Does it always follow that if you start with certain types that you always get that type in the answer? Let's find out. You can go ahead and pause this video if you'd like to try these problems, and we'll look forward to seeing you in a few moments. All right, welcome back. So here we're going to consider 3 versus 3.0. 3 is the integer and 3.0 is the float, which we recognize because this one has a decimal and this one does not. And we can also test that out in Python. So let's take a look at this problem down here with these some division problems down here of various types with the floor division and regular division. So 5, 2, 7, and 5 are all integers, and I'm just showing you this in our little table here. 16.0 and 4.0 are going to be floats, and 16 and 4, of course, are integers. And so when we do these problems, we can get the solutions, and we can take a look at the answers. So 5 with floor division of 2 is always going to tell how many whole number times. So that is going to be reported in an integer, and we get 2 times. 7 regular division with 5 is going to change this to a float. So interestingly enough, we begin with 2 integers, but the answer is going to be in float, whereas in this case, we had 2 integers and we got an integer. Now we got 16.0 divided by 4.0. We have decimal values here, so 4.0 is the answer, so we have all 3 in floats. But what about 16 divided by 4, right? I mean, it's just 4 times. Everybody knows this math fact, right? So is it going to just tell us 4? No, it's going to tell us the float, because remember, Python doesn't know before it does the math what the value of it is going to be. So it will tell 4.0. Next, we'll talk about the Booleans. The Booleans have values of true and false. The Boolean types begin with a capital letter, and the Boolean types do not have quotes on them. They are of type bool. Booleans have the true or false value. The symbols to evaluate Booleans are less than or equal to, greater than or equal to, is equal to, or is not equal to. Here's some examples of some expressions, which I've also written out for you in words, and then evaluated that to either true or false. So 2 is less than or equal to 3, which of course is true. 2 is greater than 3, that's not right, false. 2 is equal to itself, that's true. And 2 is not equal to 0, which is also true. We also have the Boolean truth table. The idea in the Boolean truth table is to evaluate whether an expression with Booleans is going to yield true or false. It's kind of like the court system, you know, tell the truth, the whole truth, and nothing but the truth. That means everything has to be true in order for it to evaluate to true. Who ate the cookie in the cookie jar? So if we say, Professor Thayer, did you eat the cookies? And Professor Thayer says, yes, I did, and aliens made me do it. Well, do you think that both of those things are true? Well, I probably did eat the cookies, but aliens probably didn't make me do it. And if I tell the falsehood second, that doesn't make it true. If I say aliens made me do it, yes, I did, that doesn't help. It's still false. And if I say, nope, the dog ate the cookies, then that's not true. And so then the whole thing is false. So really the only way for an expression in the Boolean truth tables to evaluate to true is that if everything evaluates to true. We also have this concept of the the Boolean logic. There is the negation, which means not. So for example, here we're showing you not B. So this is all things that are not B, right? So all the stuff in B is erased and A is selected. Conjunction is with and, so that means it has to be inside of both of them. So inside of both the A and B circles is highlighted here, and the disjunction is or. So whether something is in A or it's in B, it allows both of those to be selected. So these are some Venn diagrams illustrating those principles. All right, so we've talked about a number of Python types so far. We've looked at the strings, the integers, the floats, and the Booleans, and we have a few examples of those right here. There are going to be many more types in Python, which we will learn throughout the course. All right, so that concludes our discussion from today. We look forward to seeing you next time, where we're going to continue on talking about the variables and programs.